Yeah, welcome everybody to Epidemiology and Biostatistics. This is two-part presentation. Probably we'll be having a little bit longest video, but nevertheless, I would love to cover it quickly for convenience of my audiences altogether. Remember, we will be discussing about the statistics and how they are talking about it, biostatistics, which we are talking about in the first part of it. The outline, we need to understand the meaning of the statistics, the utilizations of statistics, why should we study statistics. Remember, the sources of data that goes around it. It's a 7-point program that comes around. So meaning of statistics, why it has been used, the utilization of statistics, what are the inferential data that comes around it, how the layman can very well understand and interpret the statistic thereby. Why study statistics? Because of this, which can be applicable and probably measurable by everybody, and it can be audited altogether, the sources of data thereby. The last three of the 7 points would be of clinical trials. We'll talk about planning of the service and how to succeed in statistics. So yes, the data is all where we need to generate through clinical trials. The planning of the service has to understand how can we maximize the value and so on and so forth. The agenda is simple. Definition of statistics, several reasons why statistics is so important, and we would love to distinguish between descriptive statistic and inferential statistic that comes out of it. Surveys and experiment, retrospective and prospective statistic. Retrospective is after the event. Prospective is probably prior to the event or during the event, mostly prior to the event. Descriptive versus analytical surveys thereby, and define biasness thereby. So we will talk about some part around it. Let us understand the meaning of statistic. What does statistics mean? It is basically nothing but a recorded number. Denotes the characteristic calculated for a set of a data. We'll talk about standard deviation from the average mean that it goes around it, how far the data has been located as in standard deviation. Correlation coefficient is where how a factor is related with another factor. What is the strength of this between these two factors? That is what the correlation coefficient would like to determine. A body of techniques and procedures dealing with collections, organization, analyst, interpretation, and presentation of information that can be slated and probably mentioned numerically. So, what do statistics generally us do about it? We talk about scientific challenging tasks, work upon it, primary concern with developing and probably applying methods so that not only collecting data but data that comes out with certain meaningful insights. So it helps us in analyzing data. Tasks are asked to follow to guide the design of an experiment altogether, to analyze the data and to probably present and interpret the data thereby. The use of statistics, the descriptive statistics, deals with enumerations, organization, graphical representation of the data. Example is census. This is descriptive statistics. How many gentlemen, how many ladies, how many under this age, how many over this age, how many employed, how many in service, how many doing business. I am talking about census. Inferential statistics concerned with the reaching a conclusion, as in after the census study, probably we'll have to understand whether the population is educated enough, literate enough or not, how technological savvy they are. So that's an inferential statistic that comes around it. Generalizations from the specific, as in example, opinion poll. As such, statistical method provides us a logical basis for making a decision, coming to a decision and implementing it when incomplete informations are available. So why? The question is why. I'll give you 5 reasons essential for both understanding and conducting research. Used to analyze data, can help in discriminating what is fact and what is fiction, helpful in knowing when and for what purpose a statistic should be consulted. So now we talk about the sources of data. Surveys and experiments are the various sources, and or then there are something called retrospective studies, as in case control studies. So disadvantages usually collected over other purposes and maybe incomplete. One of those reasons for the retrospective studies. Advantages are economical. It is already present out there. Answers usually obtained quite quickly. The sources of data, if we continue, prospective studies are cohort studies, batch by batch, group by group, studying the same factor. And every group, if they come up to a similar conclusion, more or less, the study will validate what we are doing is the right thing, or what we are inferring is coming to the right conclusions. Advantages: collect data over a uniform condition for specific sets of reason. better opportunities to draw appropriate conclusions, to make appropriate comparison when limiting or controlling the amount of biasness out there. Disadvantages typically not used to establish or prove a causal relationships because variable cannot be randomly assigned, cannot be randomly manipulated. So sources of data, what are we looking into? We're talking about comparison of ratios. Descriptive data provide estimates of population characteristics. Analytical data seeks to determine the degree of associations between a variable and a factor in a population, if there are any. Clinical trials will give me the definitions as a carefully designed experiment that generally considered as the best method for evaluating the effectiveness of a new drug, new treatment that we are administering. The protocol is to describe the detail in the design of the proposed research. Clearly define what you are expecting, what is your hypothesis, what is the anti-hypothesis, the null hypothesis, detailed delineations of inclusions and exclusion criteria for the study subjects. Subjects might be the patients, might be the individuals, might be the population, the sample. Descriptions of the proposed interventions and randomization process. Detailed explanation of how biasness may be minimized. Description of the procedures to minimize the errors in collection of analysis of data thereby. Clinical trial, there are two features, two key features, binding and randomization. Binding is where you study the subjects and or the investigator do not know who is in the control group, who is in the experimental group, with the purpose of reducing bias. Randomization, subjects are randomly assigned to either of the experimental or the control group thereby. What are we looking into it? We are going to study 2 by 2 tables altogether, as in the disease status on the x-axis and the risk factor on the y-axis. The disease status is present, risk factor is present. You have to take A as a scenario. If it is absent A plus B, the total would be A plus B is 0. So it becomes the total disease status is A. What happened? The disease status is absent, sorry, present, but the risk status is absent. It is C. So what are we looking into it? We are talking about, and what happened when disease status is absent, status is missing, no diseases, and factor risk is also 0. So it becomes C plus D is 0. This is 0. This is A plus B will be A plus C would be C, and B plus D is A, B, C, D. As a subject which both the risk and the diseases. B, subject with the risk factor but not the diseases. C, subject with the disease but not the risk factor. D, subject with the neither the risk nor the disease, as I've already said to you. So A plus B is all the subject with the risk factor. C plus D is all the subject without the risk factor. A plus C is all the subject with the disease, B plus D is all the subject without the disease, and A plus B plus C plus D is the total study subject. Look how things have been visually presented in front of you, and this is the work of statistics. Planning survey, formulate a clear plan of action before starting a survey. Outline the major steps to be followed out there. So I need to conclude the biostatistics part of it. It's the statistician designed efficient unbiased investigation that provides a data that he, probably she, often analyzes, interprets and present it to the others so the decision can be made. To do this work, the statistician uses a technique that are collectively known as statistics. Let me come to the part 2 of the presentation, as in epidemiology. What exactly is it all about? It is the scientific study, this the understanding of the diseases that is based on science and nothing else. So we are talking as a Webster, a branch of medical science that deals with incidences, distributions, control of diseases in a population. The Dictionary of Epidemiology states the study of distributions and the determinants of health related status or events in specific populations, and the application of this study to control the health problem. This was published in 1995. So what are we looking into it? There are three factors: agent, host, environment, and the vector. Vector is the disease borne things or the agent that carries the disease. So if this is the disease, who is carrying the disease? Is it the host carrying the disease, or is it the agent transferring it from the environment, and so on and so forth? Everything is related to one another. Remember, we are talking about the host, and host should be the focus altogether, because that is what we are looking. The host is a human body which is susceptible, which is susceptible individual. Carriers are the active individuals who are infected. Incubators are in the early stages of their infection. Convalescents are the people who have been attacked and probably are in the recovering stages. Intermittent is occasional transmission as on when on basis. So web of causations, what are we looking at? It's a number of interrelated causes, and the relationship is not necessarily a simple linear cause and effect progression as the case might be. Let us talk about the agents, the biological, sometimes called pathogens, characterized by virulence as in strength, invasiveness, ability to enter the host, communicability, ease of agent spreads from one host to the next one. You need to keep in happy about it. Next is the chemical agents. What are we looking at? We are talking about the physical, we are talking about the science, the social, the psychology, and so on and so forth. Now, there are vectors. If people have to understand what are the vectors, these are the vectors which carries the diseases from one point to another, as in the insects, the mosquitoes, anthropos, the ticks, animals, plentiful of animals. In fact, COVID-19 was spread through animals or originated through animals, as they say. Other terminology is formites, inanimate objects within the environment, such as soil, linen, doorknobs. I am sure the human waste, the solid waste, has a lot of formites around it. Common vehicles, water, tainted food, serial transfer, STD, sexually transmitted diseases from the host to the next, as the case might be. Environment is what? We are talking about weather. It can be a rainy day, it can be a sunny day, it can be a humid day, it can be anything. Then we have the social custom tradition wherein we exchange greetings, exchange foods, and probably there is a lot of touching here and there, and their acquaintances might infect the other person or person with a weaker immune system. Then comes the political and economical system. Obviously, yes, the political might and economic power ensure that the rich and the wealthy people are living in a much safe and secure environment rather than anybody else. And yes, there is a word thereby. So hosts are the individual who is susceptible. The agents are biological, chemical, physical, social, and psychological stressors. Vectors are transmitters. It can be animals, insect, human, objects as the case might be. And the fourth partner is the environment as the case might be. Definitions is epidemic, an acute outbreak of a disease that reaches a level greater than normal. Pandemic, global and widespread outbreak as in COVID-19 happened. It endemic is a higher normal of diseases, but in a limited population, certain population itself. So being models, let me go about it. BEINGS model, which is basically looking for preventions of any causes of diseases. B is for biological factors, often stated as a behavioral factors. E is for environmental factors if you can control them. I is an immunological factors. Can you be more immune? Can you have more of a zinc, iron in your diet? Probably if you have healthy habits. Nutritional factors, genetic factors, and service sectors. The social factors or the spiritual factors thereby. Remember, with every the initial alphabets of biological, environmental, I for immunological, N for nutritional, G for genetics, and S for services, which can be social and spiritual. Bean's model is the best way to calculate or pinpoint the origination or the transmission of the diseases. Behavioral factors are the lifestyle. People might have a relaxed lifestyle. People might like to have food from outside. People like to have food from unhygienic places. People might have a lifestyle which might be erratic, and there might be no rhythm for timing for going to the bed, hitting the bed, having the food, or probably resting themselves. So you need to have this thing. The type of food that they intake is also different. Might be carbohydrate laden, might be laden with fat, cholesterol, LDL fats, as the case might be. We are talking about wines, we are talking about spirits, where we are talking about alcohol, we are talking about substance abuses. Then comes the immunological factors. It is all about herd immunity, is the community immunity. By immunization, the members of the herd, the chain of transmission to unimmunized member is often disrupted. We come to the genetic factors. This is where we are looking into it. Population gene frequency appears to be stable. I hope everybody by now are very grown up and they are very sure the people from different regions of the globe looks somewhat similar. I am not going to name which sections, but you are very well aware of from which continent, which part, which people would be looking, and they will have similar sort of features in terms of physical appearances. This is nothing but manifestations of the population gene, the herd immunity, the herd community gene that we're talking about it. Then comes the services, as in the social factors and the spiritual factors. We're talking about the medical facilities, how advanced it is. Is it a iatrologic illness or injury? Social factors, what kind of support that an individual enjoys, as in family, friends, network, and members. And obviously, as the community factors, as well as the spiritual services of churches, temple, mosque, and God knows, wherever you find some kind of spiritual activities which helps you to heal your soul altogether. These are the factors that needs to be going around it. But before I wind up, I need to give you the causal research, two fundamental distinction: those who do not have the risk factor, which are independent variable, and those who have the risk factor, as in the dependent variable. Can we measure the contrast? A cohort study, group by group studies, person exposed to the risk factor and person not being exposed to the risk factor. Case control studies are case studies in certain areas, certain time, controlled subjects and non-controlled subject. With this, I come to an end of biostatistic and epidemiology video. Thank you for watching it.